Okay, so looking at 39, it says in 1990, the population of Europe was 509 million, and in 2000, it was 729 million. So these numbers go together. At what continuous rate, so that tells me I need to use E, so like compounded continuously or continuous rate is a base E. What continuous rate was the population growing during this period? So they basically want me to find the rate. So I know that generally these exponential equations follow the same format like this. I'm going to call it K, or I could call it R. So some future population is equal to the starting population times base E raised to the kt, where t is time and k is some rate. Sometimes they use R for rate. So let's plug in the numbers that we know, because we know some future amount and the starting amount. E is just a number. And we have a time that we can use, and that time would be the difference, or the number of years that have gone by between 1990 and 2000. So here I can tell my time that has passed is 10 years. So now all I need to do is plug those numbers in. So our future amount is 729 million. That's equal to 509 million. Base E, I'm going to leave K alone because I don't know what it is. And then our time is 10 years. So we have a variable in the exponent. So we know how to solve for those. We are going to have to isolate the base, and then we're going to take the natural log of both sides. So I'm going to isolate the base. Here we are multiplying by 509, so I'm going to divide by 509. Okay, I'm rewriting that. I get 729 over 509 equals e to the k times 10. And now I'm going to take the natural log of both sides, and simplifying that I get ln of 729 over 509. I'll worry about plugging that in the calculator later. And I'm going to bring down the k times 10 in ln of e. And I know that ln of e is actually just 1, so 10k times 1 is just 10k. So the only other thing I have to do to solve for k is divide by 10 to cancel that out. So dividing both sides, I get k equals, and then I have to put all that stuff into my calculator. And the rate that I get is 0.0359. And so we have a decimal here. If I wanted to convert it to a percentage, I could write our rate as 3.59%. So either one of those would be acceptable for an answer.